आगे की तरफ, जहाँ पे हमने पिछले वीडियो में दिखा था डिराइवेटिव और बेटिव का स्टैंडर्ड फॉर्मूला बेसिक से कैसे हम डिराइवेशन करते हैं, वो 2 वीडियो यूट्यूब पे अवेलेबल है और फेसबुक पे देखे तो फेसबुक पे भी अवेलेबल है। तो उस वीडियो को देखने के बाद ये वीडियो देखिए, और अभी तक चैनल को सब्सक्राइब नहीं,
अगर तुम लोग नए हो तो सब्सक्राइब करो, वो जो लाल वाला बटन है उसके साथ सूर्य नमस्कार करो या फिर अनुलोम विलोम, मुझे नहीं पता, बस क्लिक हो जाना चाहिए।
सब्सक्राइब करो। और पहली बार और आप चैनल पे आए हो तो और फेसबुक पे देख रहे हो तो लाइक
महाकाल का धमाके लाइक से ठोक दीजिए, 5000 लौटे दिख जाना चाहिए। ये 4000 के लिए मैं यहाँ पे नहीं खड़ा हूँ।
नहीं किया, ठीक है। तो हमारा टॉपिक है डिराइवेशन, ठीक है। तो डिराइवेशन ऑफ स्टैंडर्ड फॉर्मूला, ठीक है। इसलिए हमने बहुत कुछ कर लिया है, तो अब हमें डिराइव करना है सेक एक्स का एफ इक्वल टू हमारा सेक एक्स है, हमें क्या निकालना है, एफ डैश निकालना है। तो चलिए शुरू करते हैं। आपके लिए नेक्स्ट क्वेश्चन ये आपका बढ़िया, अगर एफ इक्वल टू हमारा कोसेक एक्स है तो आपका एफ डैश आपको निकाल के कमेंट सेक्शन में देना, उसका बाद ये आपका होमवर्क है, ठीक है। तो यहाँ पे हमें मिल रहा है एफ डैश एक्स इक्वल टू, देखिए लिमिट h टेंस टू 0 f of x plus h minus f of x upon h. So it will convert it into this form where x plus h will be sec x plus h minus sec x upon h. Yeah, okay. If since it is the sec function, we can write it in the form of 1 by cos x plus h and 1 by cos x h upon h. Since h is a separate function, we can keep aside for a some time, for a while, then it converted into this form. It will give us cos x minus cos x plus h upon cos x plus h into cos x. Yeah, after that what will give, it will give us and what we get after operating. Look at this. So applying the formula which I have used in the previous of the video of this series, whenever we are used to calculate the derivation of a function of sine and cos, and we have used this in the finding the derivative of a tan function. So we will keep using the formula of cos x. So it will give us, I am writing here, h tends to 0 cos x, and it gives us cos x cos h plus cos sin x sin h upon and cos x cos x cos h minus sin x sin h. You may ask to me why there is plus sign. I have or make it in a why it or do it in one line. So when we interchange the minus and a plus, minus and a minus, it converted into plus sign. Okay, so therefore it is come into this form, that limit h tends to 0. Yeah, this cos and cos x function we can use to aside and cos h. Here since cos x, okay, look at this. Since it is the cos x function, look, this is plus sin x and sin h. Now look, I am using it. So cos x cos h minus sin x sin h. If you have write down notes it down it on your paper and pen, I used to, yeah, I have to move it in this form. Yeah. I think board will be clear, inshallah. Yeah, let's do it. So keep remember this form where we have come and come, and this is the stage we have to take into the next level so that we can easily find the derivative of this function. Okay, so if you are not the calculation, so there is nothing to worry. So let's take in a further stage. So we have to can use it limit h we can separate it limit h tends to 0, since this is the plus in the function and we have a, since that is a in a denominator we have a function which will not separate the plus, since we have plus sign is the numerator, so we can separate the function and it can be converted into the two functions within along with the limit. Okay, so limit will be cos x and 1 minus cos h upon cos x cos x cos h, yeah, minus sin x sin h plus sin x sin h upon, since h is already out from it, so h is 1 by h is the multiple of all these functions, since this is function is come under the numerator of h. Okay, so it converted into limit h tends to 0 cos x cos x cos h minus sin x sin h. Okay, so easily it goes to cancel. Yeah, okay, so what we have to do, since h is the function we have, so we can easily write it. Look at this, how we can use it. H tends to 0 1 minus cos h, yeah, 1 by cos h upon h. Okay, since this is the function, so it come into cos x cos h minus sin x sin h. Yeah, okay, it's so good. Limit h tends to 0, since h is there, so we can, since cos x and sin x is separate function, we can take it tan x. Okay, tan x. Okay, look at this, how we can use it. Yeah, okay, sorry for the sound. So yeah, I have to keep quiet for some while so that I can proceed in the next level, since in my heart the pain is erased for the sake of some undoubtable reason which will not help me to go to further stage of. Okay, so let's do it in the, so sin h by h. Okay, so look here, cos x cos x cos h minus sin x sin h. Okay, so when you used to separate it, it converted into this form. Look at this, limit 1 minus cos x cos h upon h into cos x cos h minus sin x sin h. Okay, here tan x is the separate function, and when we tan x, yeah, tan h tends to 0 sin h by h, and when you, and this is converted into limit h tends to 0 cos x cos h minus sin x sin h. Yeah, since we know this is from the limit that this is function is 0 and it converted into whatever the something that it converted into the whole function along with this, it converted into 0. I am write it 0 SN. Now here tan x. Okay, tan x, this function is 1, so dot 1. When we used to put the value of now the h function in this side, we got it cos x into 1 minus 0. Since sin x is sin h 0, so since sin h we have to put the value of h here, which function is in terms of h. So when we put the value of sin h, it is 0, and since sin x is along with the sin h, so it the whole term will be vanished, so it converts into this. So finally our result is come at tan x sec x, 1 by cos x equal to sec x. So this is our derivative of dash x equal to tan x sec x. So for the sake of your convenience, I have to I am providing the answer of the question that I have given you. So when you put it, it give us a minus, if I think, yeah, minus cos x and cot x will come when you used to find the derivative. So this is for your homework. So please make a notes on this, and so that the conceptual question will be more visible for you, and which will be more helpful to visualize it, and it give the goosebump of while you are on the calculus, and to bring you new idea on a calculus and explore or calculus as a new calculus person. Even though what gender you are, you may got to know the fact. So after that, you will find that calculus is interesting, and all the related theory about the calculus and their physics, chemistry will go into well, and you will find that it is interesting, so that it will help you and it drives you to move with calculus. Yeah. So now it is time to, we have done the derivation of some standard formula, and which will help us to move in further while we are finding the derivative by using this. Since the method which I have used in my previous two video, it will have it is the some general earliest formula when the calculus was born or invented. At that time, this formula used to find the derivative of a function. Now after that, with the time passes, and people start to find the new way, so that we can easily calculate the derivative of a function. After that, taking this is for derivation as a standard basis of some function, which will help us to find out derivation of a more complex function. So it is not easy to find a derivative of a complex function which is more complex than this. So we'll keep remember all this formula while we're finding the derivative. So now, instead of using the limited concept, we'll now use some more advanced concept on the coming of the dy by dx, and we will see in this class, since we are doing the calculus for the purpose of 11th and JEE. So I will not touch the 12th or graduation level, since it is not for you. And when you are when you used to know the how to use this basic tool of derivative, and you will help you to do more, and I will do when you more about the calculus when you are in 12. And so let's look at some advanced formula of calculus. So now some advanced tools, write down it. If you have not yet subscribing the channel, pressing the notification on, and share with your friends. So make sure that, and I am providing the I think quality will be good. Anyway, I shoot a video with my best thing, then all the effort will go into the batch. This is since the quality will not come so good, so blah blah. Some advanced tool of calculus. Yeah, this is our main topic. So first number one, it is used to write in the form in terms of dy by dx, or simply f dash f1 y1 dot yn. So where dy by dx is derivative of function with respect to x, and thus also dx by dy is derivative of function with respect to y. So keep remember, this is the basic thing while you are dealing with the hard term, that not to confuse dy by dx and dx by dy. Okay, so after that, now we are able to move the next step. So some standard formula. When you are in the graduation level or doing the PhD, and you will obviously go to the research after the clearing the basics of how to put it, how to derive the theory of a new function, how to generate a new idea, and so which you can create the theory what the gap are already in the existing speed. So this is the some common. If u and b are function, if let's write if u b are function of x, so b by u plus b equal to du dx plus db dx. Yeah, so this is the first formula, plus minus I am use. Next thing, if d by dx in u b, so it is you obviously use db by dx on b du by dx. When it come into, in general, it is called L product. What L stand for? Leibniz rule product. Yeah. In general, when you use to find a derivative in n time, we will see in next video. When this video is for the purpose of board student. So if I have write it, I am going to next step. These are the main formula you have to keep it. Remember, first formula is obviously not too very tough to remember. It will come into the some general operation of what we have did in the complex number. So now next thing, dx by u by b. When we used to come that it is b whole square u d by dx b minus b d u by dx. This is the next formula. I am not going to prove it. Okay, so note down it and we'll see some question which will help us to understand how we do this. Since the past formula is very common, we'll do some question and then we will go to the next step. So let's first we have first question, the formula we have used. Now we are going to next step. Find dx by dx plus 2x square. Yeah. So what we have to do? So the formula what we have used, we will remember it. Okay. So it will give us dx upon x plus d. By using the first formula, we will keep to write by first. Yeah. Okay. What is this? d e by x is nothing but dx. We have derived it now. Since this is the constant, when I have forget to tell you, if d by f of dash x and k, then it comes that k d f of upon x. So since 2 is a constant, where k is a constant obviously, then d it comes that dx upon x square. Okay, now it will come that dx by using this formula, dx by x n, it converted into x n minus 1. Since n is 2, so it come into 2 into x 2 minus 1. So it gives us 2x plus 4x. Yeah, this is our derivative, not to worry. Okay, so this is the derivative of a function. Let's move into the next question. We will not do so many questions for that. Since this is the basics, you can use this. I have to show it how to use it, and we will do next in some cases. Now let's find the derivative of this function. Okay, let's say dy. What the formula we have used? X square 2x square by ex. So what do we have to do? First, ex whole square. Okay, first we have to derive it e. Yeah, what the formula we have? Ex d by dx 2x square minus 2x square dy dx x. So what we have find it? Obviously you can always find it ex 4x. So 2x square into dx upon ex square. Since we have find it by using, I am not taking so much speed. So since ex is common, we can take it since it is coming ex. So 4 is also, 2 is common, so 2 is also common. X is also common, I can take it, x is also. So it come into x minus e by x whole square. So ex 1x cancel, so it give us 1x minus 1 minus x upon ex. Okay, so this is the derivative. So let's look at the next step. Next is what? d by dx, 2x square dx. So first we have to, let's say this is our u function, let's say this is our v. If I have to take an u as a first function, then we have to keep unchanged while deriving first. Okay, so let's say ex is second function, so derive it e 2x. Next thing it converted to plus, so 2x square dy dx x. When we used to find it, obviously we will get it 4x plus 2x square dx. So it gives us ex x to x plus. So this is the way we can use it. Yeah, this is the way we can use it. We will do some more question while we are dealing with this on this chapter. So that's for today. We'll meet next one. If you have not yet subscribed,
अगर तुम लोग नए हो तो सब्सक्राइब करो, वो जो लाल वाला बटन है उसके साथ सूर्य नमस्कार करो या फिर अनुलोम विलोम, मुझे नहीं पता, बस क्लिक हो जाना चाहिए।
ये बड़ी अच्छी बात कही आप।
share and subscribing the channel, I have reached out to the people to find this channel, and it is your time to kind of grow this channel and you're reaching million views. Yeah, okay, I will meet next one, and subscribe this channel, and whichever you are enter and whatever is, you can come into this channel. Okay, we'll meet you next video.